Today we're going to talk about two parts that are in the same family, GRF5112, GRF5115. Okay, so story behind the two, and Ryan, you can correct me if I'm wrong. 5115 came first, and it was early on. We were learning about our p-hemmed process in the common source configuration. So we developed 5115 to be a 2-watt linear driver. What we found with our p-hemmed process was, as the FETs got bigger, we saw diminishing returns. In other words, what we projected, when we projected a size of a device over 2 watts, 2 watts and above, to give us X amount of power, it didn't quite do it. We found with the 5115 that we were right, I would say right at the point of diminishing returns where we could get a healthy 2 watts out of it. So it became our 2-watt flagship linear driver. 5112 came later as a slightly downsized version of the 5115, because what we saw with the 5115 for general purpose applications, it was fine. About 33.5 dBm compression point. What I took note of as an apps engineer was I saw a little too much variation over temperature with the linearity going hot, and quite a bit of bias current variation over temperature as well. So when the 5112 showed up, I quickly took note. It had about, on paper, about 1 dB less compression point. What I found out when I started to work with it, however, was it retained better linearity over temperature and process. I could match it, as you might expect, over a wider bandwidth. And when you looked at its performance in summation over all the parameters, temperature, process, etc., in my opinion, I liked it better than the GRF5115. So for applications with specific demands, I usually will lead a customer towards to the 5112. And I have some example tunes. The 5112, there are impedance terminations with both parts, actually in that whole family. A pin 12 termination. It's a bias resistor going to pin 12. Also, there is a linearization network off pin 14. We refer to it as the bias ground leg. And 5112 lends itself to optimization. I have an example with a 2600 to 2700 megahertz tune where the performance is just stellar. 47 dBm IP3, compression point of 31, and really stable over temperature. So that is really the comparison between the 5115 and the 5112. 5115, you can get a little bit more power out of it over a narrow band. But other than that, 5112 will cover a broader band with the same amount of power on the band edges, and as I mentioned before, do better over temperature and process. So that's the comparison between the two.
Any of you guys call me Francis, and I'll kill you.
As far as ruggedness goes, my experience would be what I see on the bench over time, and I've had years with both of these parts. As far as ruggedness goes, I've seen no problem. I don't see a tendency for damage with either part in terms of survival. Again, now we have field history as well, because that's where you're really going to see it. When a customer puts filtering in front of the power amplifier and then looks into an antenna, so the PA is seeing non-ideal viswire that it won't generally see in the laboratory. So if that's really where if the problem's going to show up, that's where it shows up, and I have not seen that problem with either. We haven't with any 1 watt or especially 2 watt PA. You're gonna run into scenarios where you're gonna see an instability. Okay, that's a fact of life. I have seen instabilities with 5115. I've always been able to correct with either rematching to decrease out of band gain, or there's been one situation where I used a ferrite for the RF choke, and that stabilized the device. So yes, I've encountered stability issues, not across the board, not frequent, but they have come up and I've been able to address them. GRF5112, I've only seen one. And it was, I talked to Ryan about it last week. It was a parametric oscillation. As you near or enter into or get just past compression points, sometimes you see an oscillation at half the fundamental frequency. And I saw that with 5112 on a 136 to 174 megahertz tune about 2 weeks ago, and I quickly fixed it by putting two-stage matching on the input and killing the gain at the half the frequency, and it went away. So yeah, I see problems, but you're going to see that with literally any PA if you work with it long enough. The thing to look at is it chronic? Does it happen too frequently? And the answer in both these cases is no. And when it does show up, can you fix it? So far, yes. They are. I've written a few PDFs to send to customers, and I can always get those to anybody that needs to read them. But the pin 12 bias line and the pin 14 bias ground leg are, the behavior is frequency dependent, and so every time I address a new tune, it's pretty much, what's the word for it when it is, the formal word for trial and error? Empirical. There you go. It's an empirical approach. There's educated guessing to it, and there's a pattern to it. You got to use your head, but generally speaking, you will go back and forth between both pins, and typically, if you're tuning for linearity on the pin 14, it's going to be resistive, inductive, or just inductive. On the pin 12, it's going to be resistive, and you can find an optimal resistor on pin 12 between 0 ohms and 500 ohms, and you can usually find an optimal small resistor or just inductive termination on pin 14 to optimize for IP3. That's usually an IP3 optimization, and sometimes it's compression point as well. So it's iterative, but there's a pattern to it. There's some logic to it. Once you work with the devices enough, you get a feel for it. I have one customer right now who is using the 5112 in multiple slots, and that customer, I was on a conference call with him the other day, and we discussed all these things, and he's gotten pretty good at it, tuning the device. And now that I think about it, one other area for optimization is with both these parts is the bypass decoupling capacitor above the choke on RF out. If you're optimizing for IP3, IMD, or ACLR, and you want to get that symmetry just right, you want to get that ACLR symmetry just right, and you want to get it down in the dirt, the terminations we just talked about are important, but so is the capacitor value above the choke, and it could range anywhere from, let's say, 10,000 puff to 10 microfarad, depending on your waveform, your bandwidth, all that stuff. So there's some games you got to play there too. Customer is not necessarily expected to figure that out by themselves. Those are the games that we play back here. And sometimes in the presentations I comment on what I did. So they can mess with it a little bit if they want to. Absolutely. So 5112 and 5115, they generally span the same frequency range. 5112 hangs on better at the high end. Okay, so you can take them anywhere from, I've taken them anywhere from 40 megahertz to 3 gigahertz. 40 megahertz to 3 gigahertz. And each tune is from my standpoint, the first time I do it is a little bit of a project, but I wrap it up, I nail it down, and we've got multiple tunes for both of them at this point. And I go back and refine them. I went back and refined, I had a GRF5115 tune from 136 to 174 megahertz. When I built it up and I was running it for the customer, I encountered some imperfections with it. I ended up optimizing it, and we've put and I replaced that custom tune out on the web. So that's an ongoing process. Yeah. So 5112 gets more bandwidth. So we'll stick with that and just understand that the 5115, the bandwidth will be a little bit smaller. I've covered up to 40% bandwidth with the 5112. That was 200 to 800 megahertz, and there was multi-stage matching, but I was able to do it. So 40 megahertz or 40% would be the extreme percentage bandwidth. Most of the tunes are less than that. One other behavior that I've noted between the two. When you do a broadband match, and we often do, that 136 to 174 with the 5115, for instance, on the band edges with RF drive, in band center the 5115 current was behaved as expected. On the band edges, because I was 136 to 174 is quite a bit of bandwidth, I saw some current overshoot prior to compression. When I dropped the 5112 right into the same match, and you can do that in a lot of cases, I did not see that current overshoot at the band edges. So in that instance, if that became an issue for a customer, I solved it with the 5112. And that's goes to show you that it literally covers more bandwidth. It didn't have the current overshoot on the band edges. So you learn a thing or two working with the two parts, and like I said, they can generally be dropped into the same layout. The only thing you have to do if you drop 5112 into 5115 layout is change the bias resistance, that's it. So they're interchangeable, almost, practically. .5110 and 5109 are low band, high band versions of about a 29 dBm power amplifier, linear driver. What I've learned is you can pretty much take 5110 down into the low bands where 5109 is and get the same results with a little bit more gain. The strong point of 5110 is when you match it at higher mid-band frequency like UMTS. I have a UMTS tune where I get 50 dBm output IP3. So the GRF5110 is a really good classic open loop linear driver where if you compare it to, say, the 55XX series or the 56XX series, they're IP3 ramps with power. right? You're not going to get 50 dBm output IP3 back at 8 dBm out with those devices by design. That's what they're supposed to do. But if you take the 5110, that UMTS tune, and you run it over power, that 50 dBm IP3 is flat. So it is a classic linear driver, and it's a good one. '5112, I haven't seen any negatives to date. It's strong. No device is perfect. I think that, I don't even know if this is a negative, but the only negative is in my mind is, to the unknowing user, it's a hidden gem. In other words, when people that are using it can get a lot more out of it, and they don't necessarily realize it, right? They're running a tune at whatever frequency, and they're getting IP3s of 40, 39, 40, and they're happy with it. They don't necessarily know that they could probably get 5 more dB IP3 performance by optimizing on those two legs. But when I start to communicate with a customer and I do something specific for them, I do that every time by default. So that's the only downside. Sometimes you can get more out of it and you don't even know it.
Thank you so much for watching. If you'd like more information, please email us at sales@guerrilla-rf.com. And don't forget to subscribe to our channel for more content from Guerrilla RF.